Assalamu alaikum. How are you, students? Hope you all are fine by the grace of Almighty Allah. So, dear students of Standard 10, welcome back to my physics class. Dear students, I have already started chapter 10, that is static electricity, and today I am going to explain some topics from this chapter, that is electric lines of force, electric field intensity, and electric potential. So, let's start the class attentively. At first, I am going to explain electric lines of force. Michael Faraday introduced electric lines of force to get an idea about electric field. If a positive charge is placed in an electric field, it would experience a force. Look here, the source charge is positive, and if a positive charge is placed in the electric field of the source charge, then that charge will experience a force, and that's why it moves in that direction. And positive repel each other, that's why it is repelled and going to that direction. If a charge is free, Q1, gaining the force instead of remaining stationary, it would move in a definite path. Look. Electric lines of force is the path of a free positive charge that moves in an electric field. So look here, if a positive charge is placed in a place, then around that charge, an electric field will be created, and if in that electric field, if any free charge is placed, look, a free positive charge is placed, then that free charge will experience the force, and as a result, by gaining the force, it will move in a definite path, and that path is known as electric lines of force. There is no real existence of the lines of force. These lines are imaginary. The electric lines of force are used to measure the electric intensity and to explain the direction of an electric field at any point. Now, look here. For an isolated positive charge, the nature of the lines of force is shown in the figure. In this case, the lines of force emerged uniformly from the surface of the conductor perpendicularly. If the charge of the body increases, then the number of lines of force also increases. That means the charge of the body and the lines of force are proportional to each other. For the positive charge, the lines of force are emerging outward, and for the negative charge, it is entering. That means for the positive charge, it is starting, and from the negative charge, it is the end point. In an electric field where the lines of force are closer, magnitude of electric field is greater there, and where the lines of force are far away, magnitude of electric field is less. Look here, the positive charge is placed, the positively charged object is placed here, and the lines of force are emerging outward. So in this position, the lines of force are closer to each other, so electric field intensity will be stronger here. But look, the lines of force in this position is far away from each other, so the electric field intensity will be less in this position. Okay. Look here, the lines of force of an electric field produced by two equal and opposite charges are shown in the figure. In this case, the lines of force emerges from the positive charge and terminates at negative charge. Look, always lines of force are emerging from the positive charge and end towards the negative charge. So here, lines of force are emerging out from the positive charge and it is entering into the negative charge. And these two charges are equal but opposite type. Look, from the positive to negative. The lines of force of an electric field produced by two equal positive charges placed nearby are shown in the figure. In this case, the lines of force go far away from each other. As a result, there will be no lines of force in between them. So look here in this figure, the x indicated sign, this place is indicated by x sign. If a charge is placed in this position, then that charge will experience no force, and this point is called neutral point. And for the two equal negatively charged object, and the neutral point will be obtained at the middle. The lines of force of an electric field produced by two unequal positive charges placed nearby. In this case, the neutral point N would be nearer to the smaller charges. Now, properties of electric field lines. We have already seen electric field lines, that is imaginary lines where a unit positive charge moves in an electric field. The field lines never intersect each other. The field lines are perpendicular to the surface of the charge. The magnitude of the charge and the number of field lines both are proportional to each other. The start point of the field lines is at the positive charge and end at the negative charge. Now I will explain electric field. So I have already told you, if a charge is placed in a place, then around that charge an electric field will be created, and into that field the influence of the charge object is seen. আমি বাংলায় তোমাদেরকে একটা এক্সাম্পল দিতে চাই। ধরো কোনো এলাকায় যদি একটা কোনো নেতা থাকে, তাহলে সেই নেতা কি চায়? সে চায় যে ওই এলাকার মধ্যে তার একটা ইনফ্লুয়েন্স থাকুক, এবং ওই এলাকায় যদি অন্য কেউ আসে, অন্য আরো কোনো নেতা আসে, তখন কি করে? এই নেতা কিন্তু চায় যে তার এলাকার মধ্যে তার একটা ইনফ্লুয়েন্স থাকে, এবং সে আউটসাইডের কাউকে কিন্তু তার এলাকার মধ্যে ঢুকতে দেয় না। ঠিক সেরকম আমরা যদি কোনো একটা চার্চকে কোনো একটা জায়গায় রাখি, তাহলে সে কি করে? তার চারিদিকে একটা ইনফ্লুয়েন্সিং এরিয়া তৈরি করে, যেটাকে আমরা কি বলি? ইলেকট্রিক ফিল্ড। অ্যান্ড ইন দ্যাট ইলেকট্রিক ফিল্ড, if any other test charge is placed, then that test charge will experience a force for the electric field of this charged body. So now look here. Here A is the positively charged body, and for this positively charged body an electric field is created around it. And from the positively charged body A at a distance r, if we at the point P, if we place a test charge plus Q, then that test charge will experience a force, isn't it? So here, as a result, so this positive test charge will experience a force. For what reason? For the electric field intensity of this positively charged body. Okay. So this test charge, positive charge, so it will experience a force, and you know force is a vector quantity, so obviously that force has a direction, and that direction will be outward. Why? Because positive repel each other. So এই টেস্ট চার্জ, এই পজিটিভ চার্জের ইলেকট্রিক ফিল্ডের মধ্যে যদি আমরা একটা টেস্ট চার্জকে নিয়ে আসি পজিটিভ, তাহলে অবশ্যই এই চার্জ কি করবে? এই পজিটিভ চার্জ এই টেস্ট চার্জটা কি করবে? ধাক্কা দিবে, রিপেল করবে। দ্যাটস ওয়াই it is directed, the force, the direction of the force is outward. So Q charge will experience a force F. So unit charge, that means 1 coulomb charge, will experience F by Q force, and this F by Q force is the electric field intensity. So look here, I have written the definition. The strength of the electric field is called its intensity if at any point of an electric field an unit positive charge is placed and the force it acquires is called the electric field intensity at that point. It is denoted by E. So we can write E equal to F by Q. That I have already explained. So again I am telling you that plus Q charge will experience F force. So unit charge, that means 1 coulomb charge, will experience F by Q force, and the force experienced by unit charge is known as electric field intensity. Okay, so E equal to F by Q, and the direction of the electric field intensity will be the direction along the direction of the force for the positive charge. But if the field creating charge is negative, then what would happen? Then also this plus Q charge will experience the force, but the direction of that force will be in this direction. Okay, isn't it? Because positive and this is negative, it would be negative, then it will be attracted, so the force direction will be towards this direction, and in that case the direction of electric field intensity will be opposite to the force, direction of the force. So E equal to F by Q, and we can write F equal to QE. So again, you know, from Coulomb's law, force equal to F equal to K into QQ by R square. Look here, I want to give one example. If it is a capital Q charged body and it is a small q charged body, and the distance between these two charged body is r, then these two charged body will experience a force towards each other. That means plus q charge and between small q charge there will be a force of attraction or repulsion. As these two charges are of same type, so there will be repulsive force, and that is Coulomb force. And that Coulomb force can be calculated by this formula, you know, F equal to K into QQ by R square. Okay, and we get the equation from the previous previous slide, equal to F by Q. So here I can put the value of F, then it will be, if I place the value of F in this equation, F equal to K into QQ by R square into 1 by Q. So this 2Q, small q will be cancel out. So what will remain? Equal to K into Q by R square. So the formula of electric field intensity can be calculated by this formula also. That means electric field intensity can be calculated by this formula also, equal to K into Q by R square. And electric field intensity can also be calculated by this formula. So if test charge is given in any map, then you will calculate the electric field intensity by this formula, equal to F by Q. But if field creating charge, that means capital K in Q, you know, that is the field creating charge. That means field creating charge means the charge for which electric field is created. So if field creating charge capital Q is given, so in that case electric field intensity will be equal to K into Q by R square. So both the formula you have to remember for doing mathematical calculation. So look, if a plus Q charge is placed, then around that plus Q charge an electric field will be created, and if at a distance r from the charge at point P, if a test charge plus Q is kept, then Look, then due to the electric field of this positive Q charge, the test charge will experience a force, and the force acquired by the unit positive charge is known as electric field intensity. Is this clear to you? You must memorize the definition of electric field intensity. It often comes. Now, I will explain electric potential. As there is intensity of an electric field, it also has electric potential. So look here, a positive charge is placed, then electric lines of force are emerging out from the positive charge. So an electric field is created around this positive charge. So in the electric field of this positive charge, at a distance d from the positive charge at a point P, if any positive charge is taken from the infinity to the point in the electric field of the this positive charge, then what will be happen? That means work will be done to bring this unit to bring this positive charge from infinity to any point in the electric field of this positive charge. Am I clear to you? That means, you know, if any positive charge is placed, then an electric field will be created around the positive charge. And if in that electric field, you know from the previous example, if any test charge is kept, then that test charge will experience a force. But here, suppose, so look, in this inside the electric field, if any at every point there will be electric field intensity, but outside the electric field there will each and every point will be acted as infinity. That means from you have already completed your length chapter. So in the length chapter you have seen some persons have near point that is more than 25 meter, isn't it? So they can for their eyes and some person can see up to 100 meter in front of his eyes. So in his case 100 meter, more than 100 meter will be the infinity, isn't it? So here the any place, that means at any point outside the electric field will be acted as infinity. So from infinity, if I take one positive charge, positive test charge plus Q charge, and I want to bring this test charge at any point in the electric field of this positive charge, then I have to do work. Here the work done, that is acted by the external agent in order to bring an unit positive charge from infinity to any point in the electric field, is known as electric potential. So I have told you the work done by the external agent. Here agent is whom? Agent, suppose you take the positive charge from infinity to any point in the electric field. So in that case you are the agent. So here I am taking the unit charge from infinity to the any point in electric field. So here I am the agent, and here the work done by the agent will be positive, because here to bring to bring the positive charge from infinity to the point at any point in the electric field, the work is done against the repulsive force. So more work is needed to be done to bring the positive charge from infinity to any point in the electric field, because you know positive repel each other. সো আমি যতই এই পজিটিভ চার্জটাকে ইলেকট্রিক ফিল্ডের কাছে আনতে থাকবো ততই কিন্তু এই ফিল্ড তাকে কি করবে, ধাক্কা দিবে রিপালসিভ ফোর্স দ্বারা। দ্যাটস ওয়াই work will be done more to bring this positive charge from infinity to any point in the electric field. But if you think this field creating charge is negative, then what will happen? Then if negative charge, the field is creating due to the negative charge, then in order to bring the positive charge from infinity to any point in the electric field, the work done will be less, because here the work is done by the attractive force. That means here less work is done by the agent, rather the system does the work. That means this charge, field creating charge will do the work, because it is negative charge and you are bringing one test charge, that is positive charge. So here work will be done by the attractive force. So in this case the work done will be negative. That means the work done by the agent will be negative. So look, for Q charge W work is done, then for unit charge, that means for 1 coulomb charge, W by Q coulomb work is done. And you know from the definition of electric potential will be what? The definition of electric potential is the work done by the unit positive charge in order to bring the unit positive charge from infinity to any point in the electric field is known as electric potential. So W by Q equal to V. That means V equal to W by Q. So V is the electric potential. The things that I have explained just now, those are written here. So look, therefore look, the more positive charge is brought from a point at infinity nearer to the body, the more work will have to be done. So within an electric field of a positive charged body, the more a point is brought nearer to the body, the more will be the quantity of potential. That means a positive charge যতই এই চার্জ বডির কাছে আসতে হবে ততই কিন্তু কি হবে, ইলেকট্রিক পোটেনশিয়াল বাড়তে থাকবে, বিকজ ততই আমার রিপালসিভ ফোর্সের এগেইনস্টে কাজটা করতে হবে। দ্যাটস ওয়াই ইলেকট্রিক পোটেনশিয়াল উইল বি লার্জার, গ্রেটার। Look here, if the body creating the electric field is charged negatively, then some work will be done due to attraction of a unit positive charge bringing towards it. A positive charge itself does work while coming from infinity towards a negatively charged body, which creates an electric field. As a result, the charge loses energy and the potential at a point in the electric field is considered as negative. How to measure the electric potential, that I have already explained. So by this equation you can calculate electric potential V equal to W by Q. That means in order to bring Q charge, if W amount of work is done, then in order to bring 1 unit charge, that means unit positive charge, W by Q work is done. So electric potential V equal to W by Q, and its unit will be joule per coulomb. So dear student, today up to this. In the next class I will show you some mathematical problem. So till then, stay safe and stay strong. Goodbye, and thank you for watching my content.